In this video and the following ones, I want to teach you the elementary operations with matrices: addition, subtraction, multiplication by a number, matrix multiplication, matrix powers, and matrix division. We'll see. Get comfortable, take out your notebook to note down anything important, and let's get started.
Current position, Caribbean Sea.
Matrix addition is something really simple and intuitive. What do you think we need to do to add these two matrices of 2 by 3 dimension? Exactly! Add element by element and the result will form. In this first example, 2 plus 5 equals 7, negative 1 plus 3 equals 2, 4 minus 2 equals 2, 6 minus 1 equals 5, 3 plus 1 equals 4, and finally, negative 2 plus 7 equals 5. To help you consolidate this idea and this operation, let's do the following example together. I will slowly say the result, but I want you to mentally perform the operation. Look, let's add these two 3 by 3 dimension matrices. Go ahead! Negative 2, 2, 4, 2, 4, negative 2, 13, negative 2, 2. Something you surely have realized is that to add matrices, both must have the same dimensions. Indeed, how could we add these two matrices if they have different dimensions? The first is a 2 by 2 and the second is a 3 by 1. This is not defined. Lastly, and although it may seem a bit boring, let me introduce you to the properties of matrix addition. They will allow you to be certain that what you are doing is correct, as well as to recognize incorrect operations. The first is the commutative property of addition. With what you have just seen, I'm sure this property seems evident to you. A plus B is the same as B plus A. The second is the associative property of addition. If you first add A plus B and then add matrix C to the result, is the same as first adding matrices B plus C and then adding matrix A to the result. It's that simple. The third is the existence of the neutral element of addition. The neutral element of a matrix, also called the opposite matrix, simply consists of changing the signs of all elements of the matrix. This way, when a matrix is added to its opposite or neutral element, the result is the null matrix. The last property is the closure of addition. It means that the result of adding two matrices is another matrix. That is, matrix addition returns a mathematical object that still belongs to the world from which matrices A and B come. As a bit of mathematical culture, you should know, in case they ask you in an exam, on the street, or in a disco, it has happened. When a mathematical operation, in this case addition, has the four previous properties I just presented when applied to a mathematical object, like matrices in this case, it is said that we are dealing with an abelian group. And that's it.
Binnacle Project.
I present to you the subtraction of matrices. Just like addition, it is incredibly simple. To subtract two matrices, we simply subtract element by element. Be careful with the sign. Look, 2 minus negative 1 is 2 plus 1, that is 3. 6 minus 3 is 3. Negative 4 minus 4 is negative 8. 2 minus negative 2 is 2 plus 2, 4. 1 minus 0 is 1. And finally, negative 3 minus negative 3 is negative 3 plus 3, that is 0. It's that simple. Just like before with addition, and as you have surely realized by now, it is essential that to subtract two matrices, both must have the same dimension. If not, as you might be seeing in this other example, it is impossible to carry out the operation.
Binnacle project.
The next operation is also very easy, the product of a number by a matrix. From now on, you will often hear the word scalar. It has nothing to do with climbing walls or mountains. In mathematics, scalar means a number. Any ordinary number that you have grown up with is a scalar. Having said that, let's see what the product of a scalar by a matrix looks like. It is as simple as the scalar multiplying each element of the matrix. In the example you are looking at, 3 times 1 is 3. 3 times negative 2 is negative 6. 3 times 5 is 15. 3 times 4 is 12. 3 times 1 is 3. And finally, 3 times negative 3 is negative 9. That's it. Just as I did with addition, and without intending to bore you, it is my duty to inform you about the properties of this new operation. You will see that, with what you just learned, they will be very easy for you and will allow you to stand on solid ground. The first of these is the associative property of scalar multiplication. Multiplying the numbers C and D first, and then multiplying the result by matrix A, is the same as multiplying the number D by matrix A first, and then multiplying the result by the number C. Intuition surely invites you to think that this is true. The second property is the distributive property of a scalar over matrices. As you can see, multiplying the number C by the sum of A plus B is the same as multiplying C by A and adding to the result C by B. There is also the distributive property of matrix over the sum of scalars. Multiplying matrix A by C plus D is the same as multiplying A by C and adding to the result A by D. If you have time and feel like it, I invite you to pause the video here and slowly do what you are seeing on the screen in your notebook. Thus, you will not only be checking this property, but you will be starting to operate with matrices, and that is truly what I want for you. The third is the existence of the neutral element of the product, and that neutral element is the number 1. Indeed, multiplying 1 by any matrix results in the same matrix. The last is the closure property of multiplication. It means that multiplying a number by a matrix results in a mathematical object that still belongs to the world of matrices. Lastly, as a bit of mathematical culture, I will tell you that this operation, which possesses the 4 properties I just presented, means that we are dealing with a vector space. And that's it. Let's do the following operation together, which will help you to get a grip on everything I've talked about in the previous minutes. Suppose we are given this matrix, which I will tell you by rows. -2, 4, 1, 3, 5, -4. And we are asked to subtract 3 times this other matrix. 0, -2, 5, 4, 1, -3. And finally add 4 times the matrix -1, 3, 2, 0, -4, 1. Do you dare to tackle it? I invite you to pause the video, because in the next few minutes I will show you the answer. Come on, go for it! First, let's leave the first matrix alone. Also, let's leave the minus sign alone, and start by multiplying the 3 by all the elements of the matrix it needs to attack. As you see, 3 times 0 is 0, 3 times -2 is -6, 3 times 5 is 15, 3 times 4 is 12, 3 times 1 is 3, and 3 times -3 is -9. In the same way, let's do the same with the 4. 4 times -1 is -4, 4 times 3 is 12, 4 times 2 is 8, 4 times 0 is 0, 4 times -4 is -16, and 4 times 1 is 4. Now we can subtract the first two matrices. -2 minus 0 is -2. 4 minus -6 is 4 plus 6, that is 10. 1 minus 15 is -14. 3 minus 12 is -9. 5 minus 3 is 2. Finally, -4 minus -9 is -4 plus 9, that is 5. And to finish the operation, let's add the two remaining matrices. -2 minus 4 is -6. 10 plus 12 is 22. -14 plus 8 is -6. -9 plus 0 is -9. 2 minus 16 is -14. And 5 plus 4 is 9. This matrix is the result of the whole operation. So laborious, but so easy.
Binnacle Project.
Now it's your turn. Prove to yourself that you have understood everything by performing the operation you are seeing. Given matrix A, which, as you see, is a 2 by 3, and matrices B and C, which are 3 by 2, calculate A transpose plus 2B minus C. Grab paper and a pencil, pause the video, and do it. You will have the solution next. Rock and roll. First, transpose matrix A. You know the drill. Remove each row and rotate it clockwise. Next, multiply all elements of matrix B by 2 and bring down matrix C. Now we can proceed to add the first two matrices. Lastly, we proceed to subtract the last matrix. You know, we subtract position by position, being careful with the minus sign in between. This is the result. Make sure you have done it correctly and quickly. There you have it. In this video, you have learned to perform your first operations with matrices: addition, subtraction, and multiplication by a number. But there is still a long way to go. As always, hit like, subscribe, and turn on notifications. See you on the next journey.